The pocket effect is a phenomenon that can occur in electrical wiring systems when conductors are routed in a U or V shape, creating a pocket or trap where moisture can collect. In electrical systems, there are often temperature differences between different parts of the system, such as between heated and unheated areas. These temperature differences can cause condensation to form on the cooler surfaces, including the inside of conduit or raceways. When moisture collects in a U or V pocket, it can create a pool of water. This water can cause corrosion of the conductors, which can lead to increased resistance and potential overheating. Additionally, water can provide a path for electrical current to flow through the raceway instead of the intended circuit, creating a short circuit. If the accumulated water becomes significant, it can cause arcing and sparking, which can ignite insulation or nearby combustible materials. This can lead to a fault that spreads through the system, causing further damage or even a fire. Consequences of the pocket effect include increased fire risk, damage to electrical equipment, circuit interruptions, and shock hazard. NFPA 784.9 mandates that conductors be installed in a horizontal or downward coursing free from U or V pockets to prevent moisture accumulation and the associated risks. To mitigate the pocket effect, the following measures should be taken. Firstly, avoid routing conductors in U or V shapes. Secondly, if unavoidable, use strip-proof or slope the conduit or raceway to prevent moisture accumulation. Thirdly, seal all openings in conduits and raceways where moisture could enter. Fourthly, use moisture-resistant materials for conduit and raceways. And fifthly, regularly inspect electrical systems for moisture accumulation and take corrective action if necessary. Condensation is a key factor that contributes to the electrical pocket effect. Temperature differences within electrical systems, such as those between heated and unheated zones, encourage condensation on cooler surfaces, which includes the interior of conduits and raceways. Water accumulation presents a risk as it gathers in these U or V-shaped pockets. This accumulated moisture can lead to corrosion of the conductors, ultimately increasing resistance and potentially causing overheating. Additionally, the presence of water can create an unintended pathway for electrical current, diverting it through the raceway instead of the intended circuit, and creating a dangerous short circuit. Arcing and fault propagation are major consequences of the pocket effect. If the moisture accumulation becomes substantial, it can result in arcing and sparking. These electrical discharges pose a significant fire hazard, capable of igniting insulation or nearby combustible materials. The resulting fault can quickly spread throughout the system, leading to extensive damage or even initiating a fire. The direct results of the pocket effect can be far-reaching, the first being an increased risk of fire caused by arcing and ignition of materials. The second consequence is damage to electrical equipment due to corrosion and short circuits. Thirdly, circuit interruptions can occur due to corrosion or shorts, leading to system downtime. And fourthly, a shock hazard due to water creating unintended conductive paths. NFPA 784.9.4.1 is a critical safety standard. It mandates the installation of conductors in a way that avoids U or V pockets, ensuring horizontal or downward pathways. This requirement aims to prevent moisture accumulation and mitigate the associated risks such as corrosion, arcing, and potential fire hazards. Prevention is key in mitigating the pocket effect by firstly carefully planning conductor routes to avoid U or V shapes, ensuring a continuous downward slope for drainage. Secondly, when U or V shapes are unavoidable, utilize drip-proof measures or slope the conduit and raceway to facilitate moisture drainage and prevent accumulation. Thirdly, seal all openings and joints in conduits and raceways to block moisture from entering, maintaining a dry environment inside. Fourthly, select moisture-resistant materials for conduits and raceways to provide an extra layer of protection against corrosion and water damage. And fifthly, conduct routine inspections of electrical systems to detect any signs of moisture accumulation and promptly address any issues discovered, ensuring continuous safety. Moisture condensation occurs due to temperature variations, water accumulation leads to corrosion and shorts, arcing can cause fires and fault propagation, and these consequences increase fire risks, damage equipment, interrupt circuits, and create shock hazards. NFPA 784.9 addresses this by avoiding U or V pockets, utilizing drip-proof measures and slopes, sealing all openings, using moisture-resistant materials, and performing regular inspections. The pocket effect in electrical wiring is a serious concern that arises when conductors are installed in U or V shapes, allowing moisture to accumulate. This phenomenon poses several risks, including corrosion, short circuits, and fire hazards. Understanding the electrical explanation behind the pocket effect and implementing preventive measures is crucial for maintaining the safety and reliability of electrical systems. The electrical explanation of the pocket effect involves several key processes, with the first being moisture condensation. Temperature differences within electrical systems, such as between heated and unheated areas, can cause condensation to form on cooler surfaces, including the inside of conduits or raceways. Secondly, water accumulation occurs when moisture collects in a U or V pocket, creating a pool of water. This water can lead to corrosion of the conductors, increased resistance, and potential overheating. The water can also provide a path for electrical current to flow through the raceway instead of the intended circuit, resulting in a short circuit. Thirdly, arcing and fault propagation can happen when the accumulated water becomes significant. It can cause arcing and sparking, which can ignite insulation or nearby combustible materials. This can lead to a fault that spreads through the system, causing further damage or even a fire. The consequences of the pocket effect are severe, with the first being increased fire risk. Arcing and sparking caused by moisture accumulation can ignite insulation or nearby combustible materials, leading to a fire. Secondly, damage to electrical equipment will happen as corrosion and short circuits can damage conductors, insulation, and other electrical components, leading to equipment failure. Thirdly, circuit interruptions will occur when corrosion or short circuits can interrupt the flow of electricity, causing circuit outages and downtime. And fourthly, a shock hazard can occur when water provides a path for electrical current to flow through unintended conductive paths, creating a risk of electric shock. NFPA 784.9.4.1 addresses this issue directly by mandating that conductors be installed in a horizontal or downward coursing free from U or V pockets to prevent moisture accumulation and the associated risks. This requirement aims to minimize the potential for water to collect and cause damage to electrical systems. Preventive measures are critical in the prevention of the pocket effect, with the first measure being to avoid routing conductors in U or V shapes. When possible, conductors should be routed in a way that avoids creating pockets where moisture can accumulate. Secondly, if it is unavoidable, use drip-proof measures or slope the conduit and raceway to prevent moisture accumulation. If U or V shapes are unavoidable, drip-proof measures can be used to prevent moisture from accumulating. Alternatively, the conduit or raceway can be sloped to allow water to drain away from the conductors. Thirdly, seal all openings and conduits and raceways where moisture could enter. Sealing all openings and conduits and raceways can help prevent moisture from entering the system. This can be achieved by using appropriate sealing compounds or fittings. Fourthly, use moisture-resistant materials for conduit and raceways. Using moisture-resistant materials for conduit and raceways can help protect conductors from corrosion and damage caused by moisture. And fifthly, regularly inspect electrical systems for moisture accumulation and take corrective action if necessary. Regularly inspecting electrical systems for moisture accumulation can help identify and address potential problems before they become serious. Corrective actions may include repairing leaks, replacing damaged components, and improving ventilation. The pocket effect in electrical wiring is a phenomenon that occurs when conductors are routed in U or V shapes, creating pockets where moisture can accumulate. This moisture can lead to corrosion, short circuits, and fire hazards. Understanding the electrical explanation of the pocket effect and implementing preventive measures is essential for maintaining the safety and reliability of electrical systems. Firstly, temperature differences within electrical systems can cause condensation to form on cooler surfaces inside conduits or raceways. Secondly, moisture collects in U or V pockets, leading to corrosion, increased resistance, and potential overheating. Thirdly, accumulated water can cause arcing and sparking, igniting insulation and causing fires. The consequences include increased fire risk, damage to equipment, circuit interruptions, and shock hazards. NFPA 784.9 mandates horizontal or downward coursing to prevent moisture accumulation. To mitigate the pocket effect, avoid U or V shapes, use strip-proof measures or slope conduits, seal all openings, use moisture-resistant materials, and regularly inspect electrical systems. The accumulation of moisture can cause arcing, which in turn ignites insulation and other nearby combustible materials. Fault propagation is also likely in that the fault can spread through the system, which can cause further damage to equipment, or even a fire.